first speaker of our theme session is Jussi Eronen. He's from Finnish National Cybersecurity Center. Yes!
Yeah, thanks. It's a mouthful. In Finnish, it's Liikenne- ja viestintäviraston kyberturvallisuuskeskus. So yeah, you need to remember that. It doesn't like roll off your tongue. So Jussi, hi. Some words about myself. I don't usually do this, but I thought that it might be helpful to you. I've been working for the NCSC for 19 years now, but before that, I started in cyber in 99, and I was working for the University of Oulu in the secure programming group. So basically, the first 7 years of my career was about breaking software. So we broke a lot of software and found bugs, and there were a lot of implications related to that. My favorite one being that a military guy later told me that they had to recall their submarines a bit earlier than planned because, well, there was a bug in the submarine system, so they had to fix those. So after some time of doing that and hearing these stories, it started to become very apparent to me that, well, this is serious business, this software and vulnerability. Software has eaten the world, and therefore we are all prey to the vulnerabilities, and that was my starting point. My research started to orient towards trying to understand the scope of our dependency with software and therefore the extent of how the vulnerabilities threaten our lives. And as a lucky break, I got into, it was then CERT-FI, Computer Emergency Response Team Finland, and now it's the Cybersecurity Center, which is like the same thing, but sexier and bigger, I guess. And there, I got involved into the other side of the table, trying to, instead of breaking stuff, trying to figure out how to fix it and how not to keep it broken. So that worked out pretty well for me. I look at a lot of incidents. I'm unlucky for me, this week is my duty officer week. Somebody else is watching the phones right now, but I'll have to go back at some point to do that. But I've seen a lot of stuff. And while I'm not a coder per se, yeah, I can code. We need to do our own tools because, well, I haven't yet found the National Cybersecurity Center shop anywhere, so we could buy our tools from. So we have to take the enterprise tools and open source tools and try to stitch and weld across those and try to make it work and try to make it integrate with each other in order to rescue the world, or Finland in our case. So I'm not a professional coder. I know a lot about vulnerabilities. I know something about code, and I hope that that is enough for this session. So this works like I talk first, and then Zach, and then you get to ask questions. I would love for you to ask questions straight away, but not today. So I already stated that vulnerabilities are serious business. Luckily, the world around us gives abundant examples of that case, and I wanted to highlight some of these cases that might be closer to your world as I perceive it. When I said that I'm not a coder, I mostly know JavaScript by analyzing malicious JavaScript, which is like looking at minified, obfuscated JavaScript, which is not fun. But lately, the session mix-up kind of vulnerabilities have been in the vogue. So that's something that, in my understanding, is quite near your alleys. There's this famous one from S-Pankki. There was one from Nordnet. Luckily, I don't know enough about these cases, so I can talk about them. So in my understanding and guessing, many of these vulnerabilities have a lot to do with either session management, load balancing, caching, or well, that's pretty much covers it. So these kind of consequences can exist. The security people always have to first start with the sexiest example up front, otherwise we lose our license. Usually the consequences are not that severe. Usually it's an XSS in the web front, for example. But even in those cases, some of the users might actually suffer a lot. This is from a couple of months back, where it turned out that some government agencies were, for some reason or another, using webmails which were vulnerable and ended up losing their secrets. So what you code is actually might matter to somebody a lot more than you might originally think, which is kind of like the theme here. Nowadays, the attack trend that has been increasing in the last few years is related, though, to the supply chain. And this is a common example of, well, it's from Friday. As I said, I'm the duty officer, so I look at all the news, so I could just pick and choose that. Okay, these are this week's vulnerabilities that really I chose this one to illustrate the fact that when you are responsible for a piece of code and publish it out there and fail to do due diligence in maintaining, for example, a repository, it turns out that other people start using your software, your libraries, and, for example, a slip-up, a malicious committer, some occurrence by which the repository goes into the wrong hands, someone will try to enter code to steal people's secrets. And it's really hard to tell in these cases where the piece of software, the library, is being used. This is from the NIST standard related to supply chain management, and I think it illustrates the point pretty clearly. When you as an organization choose, or contributor choose the packages that you want to trust, the transitive dependencies that are included in those pieces of software are difficult because, well, you kind of tend to focus on the nearest dependencies, and the transitive dependencies, the deeper down the chain they go, the amount of work to look through those increases, and the transparency related to why am I looking at this piece of code is disappearing, which is what this picture is trying to illustrate. And this goes for organizations buying things related to infrastructure, related to code, but it also is related to coding in a bit more limited sense. Of course, nowadays, the other potential attack that you might encounter is also related to dependency management, supply chain management, but at another angle. So instead of targeting the users of the code, some attack groups, for one reason or another, seem to target the developers. In this case, this was a nasty example where these packages from these popular frameworks had destructive code in them. So basically, you start to build a new project, you import a package. The package has some code that it runs while installing it, and actually that triggers the destructive routines. So they try to destroy as much of your development environment as possible. And this is why I think the current best practice is to try to separate the built environments as much as possible in order to avoid these attacks, and at the same time try to avoid making these kinds of codes yourself. The codes where when you install something, there's a lot of I don't know where this code came from that is being executed while you pull in a package. And I'm repeating myself because it's my understanding that, for example, in the Node.js ecosystem, the problem of trying to figure out the dependencies is particularly hard. I've been working in AI a lot lately, mostly with Python, and I have like problems with trying to make production systems of a library with 100 dependencies. And I thought that was bad, but boy, this is something that is on a different scale already. So this just tries to develop the point home that you really need to isolate the systems and you really need to try to minimize this footprint because, well, it creates problems for everyone. The other problem that it gives you is vulnerability management. And this is a graph from Scientia. I think it's a couple of years back, but I don't think the problem has changed a lot. For many organizations that use a multitude of different software projects have resulted in a situation where they realize that for any given 10 million vulnerabilities that appear in the wild, they can only fix 1 million. So they only can patch 1 out of the 10 packages because, well, it's a lot of work and they need to try to prioritize the patches and try to make sure that all the poke you in the eye kinds of problems are removed, but that doesn't really protect you in the end from persistent attackers that really try to find pathways into your systems. So that's, I guess, my first lesson for today. If you can avoid adding dependencies, please do so. It was, I forgot to change the heading. It is supposed to read possible solutions, and I stumbled across a solution in the previous slide already. So I'm not mostly here to talk about problems. At least I'm trying not to. That's cyber people usually do that. They come to scare people. Boo. And well, now you're scared. So I believe I've done that already. So I'm trying to move ahead from the problems towards the solution space. And the good news, I can tell you up front, I don't think it's that hard. So the basics are pretty simple, and the basics are just being a good developer, which I believe you know much more about than I do. So the first thing that I would say is important, apart from the dependencies, which kind of like got a sneak entry into the solution space, is trying to make sure that you have as little as possible of the problems of the code now, pay later kind variety. So if you can refactor your code so that there is no surmounting the, let's say, the state debt of US size heap of debt anywhere that you know about that, okay, I should really rewrite this whole server thing or these modules, the easier it will be for you in the end. And this is hard. I know that it is hard from personal experience, but I don't think it's talked about as much because, well, technical debt is a problem that's beneath the surface. So it's nothing obvious, but it's something that, well, if you're a dutiful coder, will keep you awake at night, and okay, you will know about these. And I think trying to eliminate that will not only prevent non-security related bad things from happening, but also much of the security related things, because, well, the code that isn't there will not hurt you. The other thing that I want to encourage anyone to do is to do threat modeling. So basically, I often get asked that how to do that threat modeling. Well, my kind of threat modeling is bring everyone that you know that has a stake in a system, knows something about it, expects something about it. Take them to a room, lock the door, have a whiteboard in the room before locking the door, and then explain or have them explain for you how they think the system works, how you think the system works, how the system is architected. And okay, then you have usually you have a graph. And for this graph, try to think of all the ways that can go wrong. It's as simple as that. And I encourage you to take the users and other non-tech people there, because, well, they have probably viewpoints that you didn't think of. And that's why it's useful. There are some mnemonics, that's a hard word, that you can use if you want. This is one of them, stride. So basically, for each of the nodes, you ask yourself, you ask everyone, okay, here we have a real estate agent. Is it possible that someone spoofs the identity of this person? Is it a problem if somebody spoofs the identity of this person? Is the spoofing different when it's related to sign-in, it's related to different functions of the software? And if you can't think of anything else, you go through each of the node and each of the edge and each of these, and well, that should be pretty comprehensive. I know that in practice, it might not be as simple as that because, well, things are quite large. So there are some elephants that you don't want to try to swallow with one go. So here you need to also focus to concentrate on the stuff that really matters and start from there. I don't think that you really should stop. Usually there's enough development refactoring going on that things will change. There's attacks develop, and the new developments should be taken into account. And that's why I think it's a continuous process. It's not a, I think Antti Vähäsipilä has the greatest term ever, the security end-of-level boss. So I don't think that security should be the end-of-level boss of your arcade. It should be a companion that works you through the way of your adventure. So basically trying to make sure that in every step have some thoughts about security. And that's how they don't surmount to be the technical debt related to security in your program. The rest of the basics, I think, in my opinion, are much related to common good practices. And I tried to label these as quality management, but that's probably a misnomer. The idea is that there are some things that you can set up before coding a lot. You can agree on before doing a lot of development. I know that at least for me, the development is the fun part. So you need to start coding as quickly as you can. But if you do any of this prior to doing a lot of other work, you will be probably saving your time and your nerves a lot. So make sure that you have some idea of which languages should you select. It also goes for which libraries should you select, which paradigms you should select. If you can involve some ideas related to security in there, that's a good thing. For an example from another world is Google is trying to promote the usage of Rust in the Android operating system. And what they found out that using Rust hasn't eliminated vulnerabilities. Nothing will eliminate vulnerabilities, but it has resulted to a situation. I wish I'd had a slide, but I only thought about this now here. It has resulted in the situation where there is relatively little new code that introduces memory safety related vulnerabilities, because most of the new code is written by Rust, and Rust pretty much, if you do it right, if you don't use unsafe, eliminates much of the memory safety vulnerabilities. That's a usual example. And I think the rest is code conventions, version control conventions. I think you know much more about these. Try to agree among yourselves on how to code and how not to code and how to bring in changes. But the latter two are probably familiar, and I hope they are really familiar, but I don't know. I know that CI/CD is. So basically making sure that your code is up to spec at any given point of time. That is good for functionality, that's good for robustness, but it's also good at security, especially if you have the checker tools in the loop. Of course, you would have linters. That's not a security tool per se, but it has very obvious benefits for security. But if you can include any kind of code checker, even trying to find any secrets that you commit to a repository by mistake or anything like that. Anything will give you benefits. You could use dynamic test suites, dynamic test suites, and those will really help you. The other big portion that I think helps a lot is I try to label them on the life cycle management. I'm not sure how accurate that is. Make sure that your tooling is up to spec. It's updated, it's secure. All the, if you have any configurable parameters, make sure that you have selected them thinking about security at some point. This is the good examples that come to mind come from compiled languages where you can really say that, okay, this is non-executable stack, but you probably know what I'm talking about. Secret management came in already, but that also goes for the runtime part as well, making sure, for example, it's not directly related, but I'll tell you anyway. If you make sure that the secrets are not logged, they are not a part of the kinds of parameters that get logged by any of the infrastructure underneath, that's another good problem that you solve before it actually occurred. Trying to make sure that you are using good dependency management and other types of configuration control. That usually modern tooling it's pretty easy with that, I think, in the web space as far as I've understood. As are security bill of materials, which is a fancy way of saying that I know what code went into my software, but it's not that easy in some of the more legacy areas. And have some ideas about how to maintain software, how to bring about updates, how to make sure that the updates that you present are the ones the consumer can verify that the update they load is the one that you intended. There are plenty of examples, for example, SolarWinds and other cases where attackers infiltrated the upload server and changed the update package, and there were no checks, and that's why we had NotPetya. You might know the Maersk incident that Maersk had to rebuild their infrastructure from scratch, and so on. So that was pretty much it. I promised that it would be about basics, and I promised that there wouldn't be so many of them. And I think I tried to distill the essentials into 2 slides. I still have some words because, well, I thought that everyone is asking me about AI nowadays, so I thought that I would bring in my 2 cents on AI and development and security. So I tried to iterate or list the kinds of promises that I've been hearing about related to how AI helps in software development. Of course, I use myself. Boilerplate code, it's great. So make me an X that does Y, and you have something that you can work on. I think it's great there. I'm not sure. I know that people that know what they are talking about are telling me that it's great in writing tests. I'm not sure on the rest of these things. And it's a bit worrisome now that people from, for example, the Y Combinator are telling that coding is a thing of the past. I have some friends that don't actually write code anymore. They try to evolve into specifying what they want and using Claude and on-premise LLMs to make sure that their spec gets turned into code. And they are willing to throw the code away whenever the LLM gets better. And I think, yeah, why not? I'm not sure. The thing that I'm worried about, I'm not actually opposed to these end results in the long run. I think sometime, somewhere over the rainbow, we have a world where AI can understand code. It can make the attack paths for you. But when this guy says that now they are dropping, essentially, I'm paraphrasing, they are dropping software development in to work on something that they describe as software shepherding, shepherding different agents that create software. And we are not there yet in many of these fronts. I'm afraid of the interim period between now and over the rainbow era. And I know that I stole this probably from from your Mattermost. I know that people are testing things, and here I think this is a great abstract, great summary, that there are clear benefits when you know what you're doing. And I think this is a crucial part, when you know what you're doing. And this is why I'm a bit afraid, because I know that there are a lot of people in the world, and I fear that everyone might not know what they are doing. Why is this a problem? This was a pretty dated paper at this point, because, well, it's Tuesday, no, it's Wednesday, and this was written last week, or before last week, so it's dated. In AI world, things work like that. But in those days, they stated that the 40% of the code that they produced in this particular experiment were vulnerable. We had another, oh, that's nice. I didn't intend the background to be gray, but there you have it. There was another paper related to Copilot-generated code a bit later. I wish I remembered the dates. That said that 35% of the code is vulnerable, and it exhibits 42 different types of being vulnerable. I don't think this is the question to do 42. And I knew that you might ask that. Some of you might say that, well, that's old news. So can you give me any later results? So this, I just checked that it has gone from 40 to 35 to 29.5 in Python, and has now 43 different kinds of situations where it's different types of vulnerability that it exhibits. So I think it's fair to say that it's you can't trust the code not to be vulnerable. And you might know those. You might know this, but I'm afraid that there are many people that don't. There are lots of more papers. This is one example from a couple of months back, saying that the security effectiveness varies between languages. So I don't know about your projects, but you should pay attention. I think the thing that worries me even more is that there are some papers suggesting that when people write code with AI, they tend to think that the code is better when they write it without the AI. So this has like two different viewpoints for me. So it's stating that, okay, a quarter of it is vulnerable and people are more confident on the code, and that sounds like a bad combination. So you should really be aware that you need to check the results of the code generation. So I think you should really totally use AI, but you should also trust but verify. Of course, there are now some results that state that AI can also analyze the code and find the vulnerabilities. So a proponent of AI here would say that, yeah, I have one AI model that produces the code, and then I have another AI model that finds the vulnerabilities, then we eliminate them. But I don't think we are there yet, and this kind of agrees with me. There's a lot of false positives. Any one of you that used security toolings knows that they are riddled with false positives, so you still need to work, and LLMs are not an exception. In some very specific test suits, some commercial systems, such as Expo here, are stating that, for example, in capture the flag competitions, where you're supposed to find the vulnerabilities and exploit them, they are starting to approach the same skill level as the most skilled hackers. So I think while I was saying about these days, they are faulty, but they are getting better. And the commercial side of things, I think, is also showing a lot of promise. So what I'm afraid of is that we have critiqueless use of AI before it gets better, and we will be sorting out the problems of this era for some time, because, well, you can create much more code with less criticism than ever in the world. And lastly, I thought that you probably are not interested in this, but well, I'm from the government, so I'll have to tell you about these things. So, unfortunately or fortunately, depending on which side of the fence you are, your line of business will become more regulated in the future. This is only a subset of the things that is to come, but I think the most important bits are there. So service creation and code creation will be subject to regulation, are subject to regulation, and will be subject to regulation much more in the future. So when I started in cybersecurity, there was already a lot of talk about software liability, so that when you create something, you might be actually liable for the things that it does wrong. And at those times, it was considered an atrocity that you can't do that. You will destroy the software industry. And now it's happening. So basically, NIS2 is telling you that if you are criminally negligent in producing a service and have not done proper risk management, you can actually get fines. In some European countries, personal fines for the CEO. So I guess that might mean that they actually care about these things. Cybersecurity Act also has some regulations stating that whenever, for example, cloud-based systems will be used in the future, there will be mandatory cybersecurity requirements. And I've saved the big one for last, the Cyber Resilience Act, which has been already accepted, but it will come into force in 2027, and it will state that all products with digital element have minimum cybersecurity requirements, and it also has fines. So basically, if you are criminally negligent with your code in a couple of years, somebody might actually argue that your negligence will result in you having fines, which are roughly in the same ballpark as GDPR, so a couple of % of turnover. And actually, a piece of regulation that for some reason people generally don't know about is related to radio equipment, which is not to say walkie-talkies, but anything that has wireless interface and is talking over the internet. That all those devices will have mandatory minimum cybersecurity requirements in August. So it's a couple of months away when you bring a new device that has a radio in the market, you are subject to some minimum cybersecurity requirements. Now that I've scared you again a bit, perhaps, I will say that the requirements are not much. They are related to the same kinds of things that I told you before. They are related to secret management, encryption, having no previously known vulnerabilities, eliminating anything that you know already that will hurt you. So it's probably not such a big deal if you've done quality code so far. So many of these observations that I've been talking about are a byproduct of our 3-year program into software security. While making this presentation, I noticed that we don't have an English version of the web page. So I'm hoping we'll fix that in the future. So in the course of the next 2 years, the first year was last year, we will be producing a lot more material on secure coding, on trying to make that happen. And please read it, please complain to me whenever it gets wrong, and you might even tell me what it gets right. So that was the last call of action and the end of the presentation. Thank you.